Any questions on the homework assignments or anything we've done thus far? So far, we've covered side, 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 angle, side, angle, side, angle, and angle, angle, side, or we can say side, angle, angle. Now, there's one other, and we'll talk about it briefly here, and that is hypotenuse leg. This one is a congruency statement that does work. It has a stipulation to it. It has to be a right triangle. Because if it is a right triangle and the hypotenuse and leg, the side opposite the right angle and one of the other sides, are congruent to each other, then angles are congruent. Now, the way that this looks is something like this here. Now, this is in your notes. I added it this morning. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So a right angle, hypotenuse, and leg. Leg are the two sides that connects to the right angle. The hypotenuse is the side opposite the 90-degree angle. So really we have two side angle, two sides, and then so really side-side angle is what we have here. But side-side angle does not work every single time. The only time it does work is if that angle is a 90-degree angle and we have two sets of sides that are congruent. If the angle that is not being used, or the angle that is congruent in both triangles, is not 90 degrees, we are not guaranteed that those two triangles are congruent. So 90 degrees is the only time that it does work. And we would call it the hypotenuse leg congruency theorem, as if that angle is a 90-degree angle. And this is the only time, or only one, that does work. And I just wanted to mention that because it will pop up on the test or quiz. What am I even thinking? Not quiz, homework. The homework does have one that is a hypotenuse leg. Now, what we are looking at today is CP, CT, C. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So the corresponding parts, the parts that match up of congruent triangles, are going to be congruent. Because when we talked about two triangles being congruent, we said the sets of sides that match up are congruent. The sets of angles that match up are congruent. So if we can show that two triangles are congruent, then all the other parts that we didn't talk about or use to show that they are congruent would be congruent as well. Because when two figures are congruent, well, they are the exact same. So once we can show that two triangles are congruent, then we know the rest of it will be congruent as well. The other angles that weren't listed, or the other sides that weren't listed. Because if we prove that two triangles are congruent by side, 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 we've only talked about the side lengths, yes? Well, because they are congruent by side, 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 I also know that the corresponding angles in the two triangles should be congruent as well. And we would say that by CP, CT, C. Corresponding parts of congruent triangles are congruent. Questions on this here? So really, to be able to prove these statements, we really need to prove that the triangles are congruent. So if we look at something like this here, explain how you can use the given information to prove that the hang glider's parts are congruent. Now they gave us some information. They gave us the picture here in more of a broken down model of the hang glider. Now, it's angle 1 and angle 2 are congruent, and RTQ and RTS are congruent as well. So we know that these are going to be congruent. Yes? What we want to know is that QT and ST. QT and ST. Are these two congruent? Can we be able to say it? Well, we're not giving any lengths or measures, and we haven't really been going over any way to measure those lines. But if we can say that these two triangles here are congruent, then we can say the parts are congruent as well. Now, we do have a set of angles. Now, it wouldn't be angle 1 and 2 because our angle 1 and 2 inside the triangle. No. But we can say for sure that angle RTQ is congruent to angle RTS. Well, this was kind of given to us. I'm going to put these little angles 3 and 4. Y'all can fill those in as well. Now, we're not going to be nitpicks about this, but 1 and 3, the one I drew in there, make a straight line, yes? And two angles that add together to, or two angles that make a straight line would add together to be. 2 and 4 would add together to be 180, yes? Plus 3 is equal to 180, and 2 plus 4 is equal to 180. I'll just write it out here. We can say 1 plus 3 is equal to 180, yes? And 2 plus angle 4 is equal to 180, yes? Well, by the transitive property, I can say that 1 plus 3 is equal to 2 plus 4, yes? Well, what do we know about 1 and 2? They're congruent, yes? So if I subtract them from both sides, what would we be left with? That 3 and 4 would have to be the same, yes? So the other piece of information is that we have that angle 3 is congruent to angle 4. So we do have two angles that are congruent. Do we have anything else in the figure? I wouldn't say QT and TS yet. But there is something similar in both figures. Right, because RTQ and RTS are congruent. They did give us that. So there might not be any other angles, because the only other angle is up at angle R, at vertex R. But is there something else that's shared? Line in the middle, because it's RT in both triangles? Yeah. So we can have a side length RT, which is congruent to side length RT. We can kind of say same line. Wait a minute. Is angle side one of our congruency segments? Yes. Angle side is one of the ones that work. Side angle doesn't, and angle doesn't. Well, since these two, because of this here, we could say that triangle QT R two triangle. Where do we start on the other one? Then go to R by CP CT, not CT. I'm getting ahead of myself. But how do we do it? Angle side. Any questions on we showed that the two triangles are congruent? Now is QT and ST, are they corresponding parts on the triangle? Going from 3 to that T, 4 to that T. They are congruent? Yes. So from this here, we get that QT is congruent to an ST. Now it would be by CT, CT, C. Congruent parts of corresponding parts of congruent triangles are congruent. That'd be it. Questions on this here? Let's look at the next one. Explain how you can prove that angle A is congruent to angle C. Now at this point here, do we have any information about the angles themselves? Well, no. We don't have at least, because we need at least two angles to find the third, or know something more about the angles, if they make a straight line, or any things we've proven so far, but we don't. However, if I can show that the two triangles are congruent, then their corresponding parts would be congruent as well. If we look at this here, well, angle A is beside the side length with 1 mark and the side length with 2. Is angle C in the same situation? C is between the sides with 1 mark and 2 mark, yes? So if these two triangles were congruent, A and C would be corresponding parts, yes? Okay, so let's see if we can prove that these two triangles are congruent. So what do we know so far? AB is congruent to BC. This here is a set of sides, yes? What do you know? AD is congruent to DC, and this here is another set of sides. Yes. I'm just going to write these up on the whiteboard so that we have them. So, yes. Now, we are given two sets of sides, and we would need a third set, because when we look at this here, the ones that work are side, 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 side angle, side angle, side angle, side angle, angle, side, or hypotenuse leg, which only works in right triangles. Well, with the information that I'm given, so far I have how many sides? 2. Which one of those that work with two sets of sides? Side angle, side, or hypotenuse leg, because hypotenuse and leg are both side lengths, yes? Now, are these right triangles? No. Could they be? I mean, maybe, because the figures lie. They don't always look like what they should. But most likely, we don't have any information in this right triangle, correct? So hypotenuse leg is not possible. Side angle, side, well, are we given an angle? No. So the only one that can work is side, 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 yes? Well, when I look at this here, well, BD is shared in both, yes? So we say that is congruent to BD. We have 3 pieces of information, and it does correspond to a congruency shortcut. R, side, 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 yes? So we can say that triangle what? A, B, B is congruent to triangle C, D, B. by side to side. Yes. I am so just trying to get ahead of myself. Because side, side, side would be the correct statement because that's how we know that the two triangles are congruent by that shortcut. Now, because the two triangles are congruent, we can say that angle A is congruent to angle C by PCT. So really, to be able to use CP, CTC, corresponding parts of congruent triangles are congruent, we really have to prove that the two triangles are congruent first. Any questions on this here? Are you ready for the next one? So we're back to this here. Using the diagram example 1, this one here, explain how using the new given information changes the proof. Well, if we look at this here, QRT is congruent to QRT is congruent to SRT. So these two here. We're also told RTQ is congruent to RTS. If blue shows up at all. Yep. That these two here are prove that QT is congruent to ST. So what we need to prove hasn't changed, but the rest has. Well, it's going to be QT. I cut it off. Now, we are given two sets of angles, yes? So if I look at the ones that work, the congruency shortcuts that work, that have at least an angle, well, side, side, side doesn't work because we have how many angles? Two. Side angle, side doesn't work because we have two angles given to us. So angle, side angle would work, or angle, angle, side would work. Hypotenuse leg, we need two lengths, so it's not going to work. And it'd be a right triangle. So most likely, what are we looking at? Angle, side angle, or angle, angle, side? So one of the angles that we do know for sure, we can go on and put it down, is QRT is congruent to angle SRT. The other angle that we have is that angle RTQ is congruent to angle RTS. And really, those were both given to us. That's how we knew that these were congruent. They were given. Now we just need a side length. What side length is congruent in both figures? Now that side length is in the middle of the two angles, yes? So it would be angle, side, angle. Which means we could say that triangle QTR is congruent to triangle STI. Angle, angle. Thus, QT is congruent to ST by what? C. Questions on this here? Are we ready for the next one? Prove that angle W is congruent to angle G. I mean, we can get there eventually. Because what are we given? An angle in the middle. So by what? What congruency? Side angle, side. We can say that triangle is congruent to triangle what? And this here is what you can do on the homework assignment, because you can list all three sets of angles out and work it that way, or you can do it this way here. Either way works, because by side angle side, side angle side, side angle side, say that the two triangles are congruent. Plus, what? Angle congruent to angle G by CP, CT, questions on this here? Let's look at one more because I feel like y'all have got the hang of this. Yes? So if we look at this one here, because we do have E and S, what other angle do we have? The vertical angles at point D. So we do have these angles, and a side. And are the angles oriented correctly? Because if we look at angle with one, angle with two, and a side. One angle with and a. Yes. By angle, angle, side, we can say that what? Triangle FD is congruent to triangle RDS. Thus, what? Yes. Now on the test, I'm going to want you to write out the angles and sides that are congruent that we're using for side angle, side angle, side angle, and these here. Any other questions on this here? Now this one here would probably be a hypotenuse leg, because if we could say that the hypotenuse, it does say that the hypotenuses are congruent, and we have one of the side lengths, then we could say it's true by hypotenuse leg. And it's really based off the fact that M is the endpoint of NK located, so this here, explain how you can find it. Yeah, but that's a little hard to see. And that is all we are doing today. Now, for the rest of the week, I have not had time yet this morning to update the week schedule. This is not the last one. Tomorrow and possibly Wednesday, we're going to do something called flowchart proofs, if y'all remember those from the proofs chapter. And they are all set up. They're 100% set up for us to work through. So they are all set up to do. It's just filling in what we need. Now, as I hold this up here, did everybody get the assignment written down? Okay, I need to go back a little bit further. I'm gonna pause the video because that's all we're doing here. Remember